Hello, my name is Anthony, and this is my Lab 1 report. So we know that most objects gain a charge when rubbed or pulled apart, but how much? The purpose is to determine how charged an object becomes from this. In this experiment, we charged tapes by sticking them to a surface and ripping them off. Then, using the physics principles that opposite charges attract and like charges repel, that the net force on an object with no acceleration is zero, and that the main vertical forces acting on the tapes were the gravitational and electric force, I found the charge to be 1.67 times 10 to the negative 8 coulombs. I also created a code model that calculated the charge using the same physics principles. The model code uses two basic assumptions: that there is no air resistance because this has a minute effect in real life, and that the tapes have the same charge evenly distributed throughout the length of the tapes. And this is because the tapes are uniform and identical. Using the second assumption, the model represents the charged tape as a line of charged particles and uses this to calculate its electric field and force. It also calculates gravity using the definition force equals mass times gravity due to acceleration. For this experiment, I used 3 tapes with the dimensions shown at the top. I stuck the first one to the table to be used as the surface. The next 2 I stuck on top of the first and then ripped off to make them charged. When the 2 tapes were close to each other, they repelled, which makes sense because they have the same charge, and same charges repel. Also, then, I grabbed a plastic pen and rubbed it through my hair to give it a negative charge. I found that the tape was attracted to this, so that means that the tape has a positive charge because opposite charges attract. To get the magnitude of the charge, I used a setup like in the image shown. I placed one tape between 2 books and then put another tape beneath it and moved it close to the top tape until it began floating, at which point I measured the distance to be 2 centimeters between the 2 tapes. Here the surroundings are the lower tape and the earth, and the system is the upper tape. We also used the assumptions that both tapes have the same net charge because they were charged the same way, and that the tapes can be treated like a single charge at their center of mass. These assumptions were also used because we only need an approximation from the experiment. When the upper tape was floating, the 2 vertical forces acting on it were the gravitational and electric forces, as shown in the free body diagram. Since the tapes have the same charge, the lower tape caused an upward force on the upper tape, so it floated. And when the upper tape was floating, it had 0 acceleration, which meant its net force was 0. This meant that the 2 forces on that charge must be equal in magnitude, which is shown in the equation at the bottom. Now, using the definitions of the forces, I can rewrite the equation. Also, as said in our assumptions, the 2 tapes have the same net charge, so you can set this equal in the equation as well. And the initial conditions are listed at the bottom of the slide. Now, plugging in the initial conditions along with the mass and the distance between the tapes, I can solve for the value of the charge of the tapes to be 1.67 times 10 to the negative 8 coulombs. Also, using the magnitude of the charge of the electron, I can find the number of electrons that left the tape to be 1.04 times 10 to the 11. Electrons left the tape since the charge of the tape is positive. Using the dimension of an atom in the tape, I found that there are 9.52 times 10 to the 15 atoms in the tape. Then I found the ratio and saw that 1 deficient electron exists for every 91,538 atoms in the tape. Now onto the code, the link for which is in the description. The first lines introduce the initial conditions and the mass and charge of the tape. The next function is one that determines an electric field, and the next function creates the tapes as lines of point charges 2 centimeters apart. Next, the electric fields of each top charge are found by superposing the electric fields of the bottom charges. The net electric forces of each top charge are then found, and these are superposed to get the total electric force on the top tape. Then, vectors are created for the electric force and the force of gravity, and their magnitudes are printed out as well. Then, I found the computational charge to be 4.045 times 10 to the negative 9 coulombs, and I found this by setting the force of gravity equal to the electric force. So, I got 2 different values for the charge of the tape. Both the experiment and the code calculate the charge the same way by having the net force on the tape be 0 and then setting the force of gravity equal to the electric force. Both also use the assumption that the tapes had equal charge. However, the experiment assumed the tapes to be a single point charge, while the code assumed them to be a row of point charges. Also, the experiment had error due to human error in handling the tapes. If protons had a negative charge and electrons had a positive charge, the only thing that would change is that the tape would have had a negative charge. This is because if you flip the 2 charges, it would flip everything else, and so everything would stay the same. For example, the tape would still be attracted to the pen because the pen would now have a positive charge. Also, it is important to touch the tapes as little as possible because when touching the tapes, it causes a transfer of charges, so the tape's charge would decrease when doing so. Summing it all up, the purpose was to determine how charged a piece of tape becomes after it's stuck and ripped from a surface. I found the tape to be positively charged because it was attracted to a negatively charged pen. I then found the distance between the tapes when the upper tape began floating, and using this, along with the fact that the tape's electric and gravitational forces were equal, I found the charge of the tape. Then I used a code to model the experiment and found the charge that way as well. The code in the experiment used the same setup but also different assumptions, and the experiment also had some error, but overall it was still accurate.